Hey everyone, welcome back to my numbers and series. This is the second video in our estimation series, and today we're going to be covering the easiest part of multiplication. So multiplication is kind of a wide variety of estimation, and this is going to be the easiest version. In future, we're going to consider more complicated forms where you might have to think about different things, but in this video, we're just going to think about pure multiplication. So what this video consists of is essentially just rounding. Like our previous video, we have to assess when the risks of rounding are going to balance each other out, when they're not going to exceed the 5% rule that is still there. It is still 5%. And we're just going to try to simplify our calculations as much as possible without being wrong or too wrong. So a typical problem would look like 399 times 403. And so what we would do for this problem is basically just see if any of these round to nice numbers. And usually they are going to. For example, here this rounds to 400, and this rounds to 400. And note that I'm rounding one of them up and I'm rounding one of them down, which helps to cancel out the error a little bit. And also, note that the magnitudes of each of these error, right? Like 1 over 399 and 3 over 403, those are all less than 1%. So there's pretty much no way it's going to create an error that is greater than 5%. So when you're kind of running this risk assessment in your head, this is what you should be kind of thinking, and you're going to be like, okay, this is pretty safe for me to do. I will proceed with the multiplication. So of course, with the multiplication, what we're going to do is just 4 times 4 is 16, and then we have 1, 2, 3, 4 zeros. So this is what we write down as our answer. Not so bad, right? Well, it's pretty much the same for the other problems. For example, 252 times 198. Once again, we're going to see what nice numbers does this round to. So nice numbers would be like 125, 250, 500, 200, 20, 50, anything that has a lot of zeros or a lot of twos or a lot of fives in it, basically. And here we're going to see this is 250. Once again, this is an error of less than 1%, and this is 200. Once again, this is also an error of basically 1%, and also, once again, we're rounding this down and we're rounding this up, which helps to also balance out the error, which is, really good for our accuracy. So the answer is going to be 25 times 2 plus 1, 2, 3 zeros at the end. 50,000. Not so bad, right? Now we're going to have 543 times 702. So this is a little bit of a less nice problem, but in these kinds of problems, less nice still means pretty nice. So 543, what could that round to? If you're trying to be safe, you could round this to 540 in order to establish another error that is, again, less than 1%. But here, what I would do is round this to 550. Because 550, that's not a huge change, right? You're only rounding up 7 compared to a number that is already in the 500s. That's barely like a 1% error, less than 1.5% error. And also, what I'm thinking in my head is I can counterbalance this error just a little bit by rounding 702 down to 700. So this is still going to be very, very close, pretty much no risk of being outside of that 5% boundary. So what I'm going to do is 55 times 7. If you don't want to do this in your head, you could think about 55 times 7 is really 11 times 5 times 7, which is 35 times 11, and then you could use our 11 trick, or you could simply FOIL it out. Whichever way you choose, you will find that the answer is 385. With 1, 2, 3 zeros at the end. Not so bad. Our third question, once again, we are going to be rounding, and this time, again, we're going to be rounding one number up and one number down in order to mitigate our error. For example, 49 and 51, we see 40 is already a pretty nice number, and there's not really anything that can round to safely, so we're just going to leave it alone. But 49 and 51, those are tantalizingly close to 50. And once again, we see that we're going to round 49 up and round 51 down, which is going to make the error virtually zero. In fact, the error here is like 0.04% or something like that. So pretty much nothing. So we're going to write 50 times 40 times 50. 5 times 4 times 5, that's 100. With 1, 2, 3 zeros at the end. We're getting some pretty nice numbers over here. And that is the intent of these problems. Last question, going to be a little bit more computationally intensive, but not by much. And you should essentially see the idea immediately when you see these problems. For example, 79 times 81 times 51. multiples of 10s are nice. And this is what we have right here. 79 is very close to 80. 81 is very close to 80. And notice once again, this is being rounded up and this is being rounded down. And so the error goes to basically 0. And 51, we're going to round down to 50. That is about a 2% error. But considering that these two errors kind of cancel out, we know our final error is going to be around 2%, which is pretty safely in the range of plus minus 5%. So we know that this is going to be times 50. And so our final calculation would be 8 times 8 times 5, which is 320, with 1, 2, 3 zeros at the end. So this is the simplest kind of multiplication. No division in estimation usually, just multiplication. And this is the kind of multiplication where all you have to do to approximate the answer is round. And so they're always going to make it decently obvious for when you have to round, but it is still important to train these risk assessment capabilities. For example, 543, you could have rounded it to 540, but 550 is a slightly nicer calculation that could save you just a tiny bit of time that could maybe get you one extra question on number sense. Every little bit of time matters, so it's still very important to train these capabilities. And of course, multiply fast. So that's about it for this question, this kind of question, and we're going to do multiplication 2 next time with slightly harder questions. But if this makes sense, you are going to be pretty well set for those. Thank you guys for watching, and I'll see you next time.